Hello, everyone. Good morning, good afternoon, and good evening. I think we have people from the three time zones here. My name is Amreesh Phokeer. I work at the Internet Society as an internet measurement and data expert. I work on multiple projects, including manners. Today, we will talk about route origin validation, which is a very important component of securing the routing infrastructure. I'm joined by three excellent panelists, starting first on my left, Cecilia Testart, who is an assistant professor at Georgia Tech. Hello, Cecilia, joining us from Chile. Is that correct? Yeah. Next is Tijay, who is an assistant professor at Virginia Tech and joining us from South Korea. Hello, Tijay. And then we have Haya, who is a professor at the Goethe University in Frankfurt. Hello, Haya. Great. So the aim today is to talk about the different challenges and the different techniques that we can make use of to measure the deployment of ROV. We have seen over the last few years a quite big uptake in RPKI, more and more ROAs being created, a higher coverage of the IPv4 and IPv6 space. But at the same time, we're also encouraging operators to deploy ROV as much as possible. But the challenge, of course, lies in how do you measure ROV? How do you make sure that the data you're getting when you're trying to measure ROV is correct? Because it's very difficult, as we will learn today, how to get ground truth about ROV deployment. Without further ado, I would like Haya to give us maybe an overview of ROV measurement techniques, maybe the latest research work that happened in that space. And perhaps you can tell us a little bit about the challenges as well. Thank you, Haya. Feel free to introduce yourself more elaboratively.
Hi, everyone. My name is Haya Shulman. I'm a professor at the Goethe University in Frankfurt, and I'm leading a research department at a research institute for cybersecurity. This is Fraunhofer ICT. And I'm going to give an overview of this development of ROV measurement. And I saw that actually there were discussions on RPKI and ROV and ROA. So I think you don't really need the components. So maybe I will really quickly just say that there are the repositories which host the RPKI objects, and we have the relying parties who retrieve them, who fetch them, validate them, and then BGP routers fetch from the relying party caches, from the caches, and use them to make routing decisions in BGP. And the basic idea of the validation is to check which ASs, or to check on which route invalid routes are dropped and valid routes are not dropped, and then to use this to make an assessment about ROV deployment. So in contrast to ROAs, which you can just download and to have locally and analyze them and see which prefixes are covered, ROV is much more challenging because it has to be done remotely. And so this is the basic idea which underlies all of this measurement of ROV. So I'm going to show you this evolution of these ROV measurements. And I'm going to start right here. Yeah, so the basic idea is to check the reaction of a network to invalid and valid announcements, and by measuring the route to destination prefix. If valid route is seen on the vantage point, but the invalid route is not seen, then there is ROV enforcement on the path. Okay. And here's the timeline. So deployment of RPKI filtering started in 2009 with a first running testbed hosted by RIPE. And the goal was to test this new standard and to see how it works. Now in 2010, Randy Bush had a series of presentations to promote this new standard, RPKI. In 2011, there was the production-ready hosted RPKI by RIPE, and Deutsche Telekom created ROAs for their prefixes. So this essentially jump-started the RPKI in the RIPE region. And since then, a lot of effort has been done to measure the deployment of RPKI and to understand its effectiveness in the internet. And in 2017, we performed the first global measurement of ROV adoption rate. This was in a paper that was published at NDSS. The method in this first measurement used control plane measurements. So we used route views, vantage points, and it was an uncontrolled experiment. Namely, we used existing valid and invalid ROAs, and we classified in that measurement an ROA as ROV enforcing if it was forwarding the RPKI non-invalid route announcements, namely either valid or unknown, but dropped the invalid ones. And so what we found was the 3 out of top 100 ASs in the internet were performing ROAs. And then in 2018, Goethe et al. Developed a control plane experiment for measuring ROV. And at the same time, we in 2018 also developed a control plane and data plane experiment. So first on the control plane, Goethe et al. And we extended the previous passive measurements, which we did at NDSS in 2017, to active measurements by announcing our own prefix ranges and controlling the ROA states. So the first measurement, there was no control over anything. There was all passive, just observing how the networks announce their prefixes and using the existing ROAs. And then the next step was to do this in an active experiment and controlled experiment. So announcing our own ROAs and changing the states. And the reason for this was to reduce noise in the measurements, because if you control this, you can improve the accuracy. Now, another problem is that the inherent limitation of control plane is that it has limited number of vantage points. So you don't see a lot of the internet. And so to extend the number of vantage points and to improve the coverage, we also used data plane and specifically RIPE Atlas for data plane measurements. We sent trace routes from multiple Atlas locations, and that was in 2018. And then this followed with the PALM paper in 2020, who Testart et al., who explored to what degree the registration in the RPKI protected networks from invalid routes. And they did a longitudinal study of filtering behavior of transit providers in the internet, and also measured the visibility of legitimate and illegitimate prefix announcements in the global routing table. Testart et al. In 2021 performed control and data plane measurements. And this was also followed by APNIC measurements, which combines a data and control plane experiment to test ROV deployment over reachability of destinations with different ROV validity. And for the data plane measurements, instead of using RIPE, also RIPE Atlas was used. And this also allowed to increase the coverage much more significantly, because RIPE Atlas, as I will show you shortly, is a little bit biased towards Europe and also limited. The measurement probed how many users in a specific AS can reach an invalid prefix, and based on the results, it drew conclusions on the ROV enforcement status of those users' ASs. The measurements were done automatically on a client system when the browser tried to download objects, and in addition, they used Anycast to inject their route from a large number of routers instead of using 2 points, like is used by Cloudflare. And this reduced significantly the false positives rate. Now, Cloudflare project, this is a community-driven effort to measure ROV implementation of large providers. The project provides a web page to test ROV enforcement of providers by probing their reaction of a client to valid and invalid announcement, and client can reach the valid announcement, but not the invalid one. Then they conclude that the provider of the client enforces ROV. Users can contribute to the project over a GitHub page and update the status of their own providers in the dataset. This approach is not as scalable as the one of APNIC, because they require support of the volunteers, and also the dataset is small with only 380 ASs just a month ago. And also smaller ASs with fewer clients, less likely to have a user that contributes. And so the dataset is biased towards larger providers. And since the measurement methodology relies on 2 announcements picked up by a single vantage point, it leads to errors in cases where ROV in an upstream provider filters the invalid announcement. So the provider of the user is then can mistakenly be classified as ROV enforcing. And then two recent works, one, our work in Usenix 2023, where we combined control plane with data plane using also RIPE Atlas, but added a classification scheme to reduce false positives. And a recent project, ROV, which uses control and data plane also, but also on the data plane, different from other projects which use RIPE Atlas or clients, they use an IP-ID-based side channel to infer information if a network enforces ROV or does ROV filtering or not, which is a very interesting idea. They have a project page, and you will see more information about this project in the follow-up talk. And what I'm going to tell you now is about the limitations of control and data plane. So we measured the limitations and characteristics of control and data plane. And here you can see that control plane has a higher percentage of points in North America, at least for our measurements. On the other hand, the data plane measurements, they primarily originate in Europe. Therefore, the control and the data plane measurements have slightly different view of the internet, which of course creates some bias. We also found a different distribution of AES types between the measurements in the control and data plane, that we have higher percentage of stub AESs and internet exchange points in the data plane than in the control plane. The difference perhaps is caused by the observation mode, because the data plane can observe stub AESs, because some of the stubs host an Atlas probe, and so they are visible, even though they do not forward traffic themselves. Internet exchange points are visible because routers in the peering LAN reply to ICMP messages when we send trace routes, even if they do not append to a AES number. On the other hand, in contrast, IXPs and stub AESs, they are not visible on the control plane. Stub AESs are not visible on the control plane because they do not forward traffic to our destination here's, and IXPs do not append their number to the control plane path, so therefore they're not visible. To summarize, the idea in measuring ROV is to understand this behavior of a network remotely to valid and invalid routes. There are two aspects to this. One aspect is data acquisition, how data is collected. And we saw that combining data in control plane provides the best optimal coverage. And of course, on the data plane, ideally would be good to have measurements which cover much more than RIPE Atlas, for instance. But Atlas already substantially improves the coverage that just the control plane offers. So on the one hand is the control and data plane, then data analysis is the second aspect. And here, changing, alternating between valid and invalid pairs and ROAs using classification scheme can reduce substantially the error rate, the false positives, false negatives, and can improve the measurement. So essentially the direction that we believe should follow is using data plane approach, or perhaps a combination of data plane approaches, to improve the coverage, and leveraging classification scheme, which in our recent paper that we published at Usenix, we substantially extended this, would provide accurate results. So that concludes my statement.
Thank you, Haya. Thank you for giving an overview of what's research on ROV measurements, and also the challenges that it entails, also the issue of bias, especially if you're using measurement framework such as RIPE Atlas or others. As in any measurement work, there is an element of bias that obviously we need to take into account. Tijay, you can go ahead talking about the ROV project.
Hello, everyone. My name is Tijay from Virginia Tech. So I'd like to talk about our recent project, which is called ROV, which is trying to measure and understand the ROV status at scale. One disclaimer of this project is not measuring the ROV deployment of the AES. Our measurement purpose is to understand how ROV is currently widely used in between AESs. So this is my short introduction. Assistant professor at Virginia Tech, and I am mainly focusing on internet security protocols related to PKI, DNSSEC, and HTTPS, and email security, and so on. I believe most of you are familiar with our PKI, but for those who are not familiar with this, let me just briefly give you an overview. It is a PKI framework designed to secure internet's routing, especially for BGP. Currently, more than 40% of announced IP prefixes are verifiable with RPKI, which means network operators publish a cryptographic object, which is called ROV object, that contains the mapping between IP prefixes and the authorized ASNs to announce. Basically, in case of the Virginia Tech, announces IP prefixes and its own ASN number. It helps routers to use this cryptographically verifiable database to find the authorized AS number for the announced prefix. There are two perspectives here. The first one is the resource owners needs to create an assertion called ROA and upload it to the registry. And the other perspective is routers need to download these objects and verify BGP announcement against that, which is called ROV, which is the focus of this session. Talking about these two questions, actually answering the first question is, as Haya said, relatively straightforward, because all these ROA objects have to be uploaded to the 5 RIRs repositories. So we can just download them and locally analyze how these objects are registered by which ASN number and the coverage of IP prefixes. And answering this question is relatively straightforward. But the thing is, how network operators use RPKI to filter invalid BGP announcement, it is not that easy because we simply don't have any access to the routers. Let me recap the portion of Haya's talk. There are many successful previous approaches, namely a few is bgpsafety.com managed by Cloudflare. What they do is when you go to this website, it basically requests two URLs. The one is valid.rpkicloudflare.com, which has the correct ROA. And the other one is invalid ROA. So the IP prefix is announced by a wrong AS number, which is against the registered ROA. So it is a crowdsourced measurement. It is good. It is also very well-known strategy, but sometimes it is not scalable because it is crowdsourced based methodology. So you have to hire many people to estimate the ROV status of many ASNs. So sometimes it is not accurate because it is well known that some ASs do not filter the announcement coming from their customers because of maybe revenue. And also there are some crowdsourced based spreadsheet, RPKI exposed. When you go to this website spreadsheet, you can tell some ASs are listed their policy regarding their ROV for the different connections. Or you can rely on blog post, mailing list, or Twist, but sometimes it is not accurate and also it is not scalable at all. Also, sometimes network operator, they change their policy. For example, some ASs, after deploying ROV, they may feel that there are some issues deploying ROV, so they retracted the ROV. So Rovista, I hope that I could talk about this, our technique, very long time, but due to the time constraint, let me just give you a very brief understanding. So we are using IP-ID side channel technique. In a high level, this IP-ID side channel technique has been used in many areas. For example, measuring censorship or measuring the traffic sent by host. But using this technique, it allows us to infer the connectivity between two remote hosts. So we don't need to control the vantage points. We can use remote end host. The other one is we are using in the wild invalid prefixes. Right top figure shows percentage of the prefixes covered by ROA. As you can tell, it is increasing. But the thing is, not all this BGP announcement covered by these prefixes are valid. Sometimes it is misconfigured due to misconfiguration or attack. But anyway, from our measurement, at least 0.5% of these BGP announcements, which are verifiable with RPKI, are invalid. So in a very high level perspective, what Rovista does is we find RPKI invalid prefixes announced by only one AS. And after that, for each AS that we are investigating for the impact of ROV, we select a minimum 10 hosts within each AS that we can use to apply IP-ID technique. After that, we determine whether all of them are unable to reach the hosts associated with the RPKI invalid prefixes. For example, if we find one AS which they can access to all maybe 10 or 20 RPKI invalid prefixes that we can find, then we can assume that, oh, this AES may be doing some filtering, right? After that, finally, we calculate ROV protection score that represent the percentage of RPKI invalid prefixes that an AES cannot reach. If one AES deploys ROV, then their score should be 100%. If this AES filters invalid announcement, regardless of the source of the announcement, for example, they also apply ROV for the announcement coming from the customers, then this AES's ROV score must be 100%. The details are on the paper, but the thing is, it hasn't published it yet. So if you'd like to take a read, please let me know. We've been actually doing this measurement since 2021, and we covered more than 27,000 ASs and 200 countries. I'm going to show the results at the end of the talk, but the results are available on this URL. As Amreesh briefly talked about, one of the key challenges when designing this ROV measurement technique is cross-validation. We tried our best to collect all the AS's policy regarding the ROV. So for example, we tried to AS's network operators individually, or we collect the announcement from the network operators through their blog posts and nano mailing list. And also thanks to Manners, we used a network operator survey. Also thanks to ROV. So this is the short list of that we used. And fortunately, ROV protection score is, most of them are perfectly matched with their official announcement. But there are some cases that are not consistent with our research. So we try to reach them individually, and a BIT, we got the response from them. The thing was, they announced ROV deployment on 2018 or so, but later they found some ROV bugs due to their Jupyter router issues, so they retracted at the end of 2018. So that was the reason why ROV protection score from Rovista is 0%. When we are focusing on top tier ASs, and we found that 5 ASs are not deploying ROV at all. For example, Zayo, and Telefonica, Verizon, Deutsche Telekom, and Verizon. Then one case study we can do with Rovista, we are measuring entire IPv4 spaces every day. And one question should be, how quickly Rovista detect ROV deployment or ROV impact? Fortunately, during our measurement period, we found 2 ASs, Orange and KPN, officially announced their ROV deployment. This graph shows the x-axis date and y-axis their ROV protection score. In case of Orange, they announced ROV deployment on June 27, 2022, but we found a spike. As you can tell, ROV protection score jumped up from 0% to 100% on June 6. Similarly, KPN announced on March 16, but we found a spike on March 14. So we believe that before announcing it, they run it for a maybe test purpose. And after they find that, oh, ROV is working fine, then they announce their deployment. So there are some also collateral benefits of ROVs. The definition of a collateral benefit is, if the upstream started to deploy ROV, then all the other downstreams that are relying on that upstream also gain the benefit of ROV. So we found that in case of KPN, all 5 ASs who are the customer of KPN, their ROV score also jumped up to the 100% at the same date. But we also found that some 2 ASs, they do not change ROV score at all. And using RIPE Atlas measurement, we found that there are other extra routes, so that even though KPN activated deployed ROV, still these 2 customers have alternative route to access to the RPKI invalid prefixes. Because we run this measurement for 15 or 60 months, we can find that the percentage of ASs with 100% ROV protection score is increasing, which is good news, but it's still less than 10%. So here's the quick summary for Rovista. Rovista is data plane based methodology using in the wild RPKI invalid prefixes and IPI decided channel techniques. One of our focus was to measure this ROV impact, ROV status, without gaining any access to the routers and also at scale. We are releasing our research at this website. It's still a beta version, and we are still trying to improve it, but let me show you later. Before concluding my talk, I would like to talk about some limitations of our work. ROVista cannot measure the score of IXPs since it is invisible for us to find measurement nodes because we are using IPI design technique. And ROVista relies on hosts announcing RPKI invalid prefixes using a public BGP collectors like REES or ROV views. So we may have some limited coverage and sometimes it may not be accurate. Also, I would like to point it out again that ROV protection score does not directly indicate the ROV deployment. So 100% ROV score does not necessarily mean that the AS has deployed ROV because it may be due to their providers. So I'd like to show you this website. I know this website is still very premature, but when you go to this website, you can see all the tables that list all the ASs that we measured so far. This table only shows the most recent ROV score. So if it is 1, it means we find that all the hosts in this AS were able to filter all RPKI invalid prefixes that we could find. And also you can find a search function, for example, orange, and you click this ASN number, then you will see the ROV protection score jumped up from 0 to 1 this date, June 6. And we believe that they actually activate deploy ROV on this date. If you're really interested in what kinds of ASs we tested to measure ROV status of orange, then you can click this graph. Then you will see all the ASs and the invalid prefixes that we could find on that date is here. Okay. All right, thank you so much. And let me stop here.
Thank you, Tijay, for the overview of your latest research on measuring ROV. Very interesting technique using a side channel to measure ROV. I think this is quite novel. Cecilia, now it's your turn, talking about the challenges that you receive or the feedback that you receive rather from operators.
Okay. I recently presented part of this work to operators at NANOG, and I received a lot of feedback, and they really like it, so I wanted to share this with you. First, a little bit about me. I'm an assistant professor at Georgia Tech. I sit in the School of Cybersecurity and Privacy with a joint appointment in the School of Computer Science. And my research area is in internet security and policy. I'd like to think about how we can use other tools to improve internet security. And I'm also in the internet measurement community. So you've heard a lot about RPKI and how to measure ROV deployment. My view of how to measure ROV deployment started from my PhD research back in 2017, 2018. I started studying on the hijacking side of BGP, and I found like it was so easy to hijack BGP. So what could we do to prevent such easy hijacking? And then I jumped into RPKI, and initially I thought that my measurements were not correct because I couldn't measure any deployment. But then running again my code in 2019, I found a little bit of deployment. What was happening that when I wrote the code back in 2017 and 18, there was so little deployment that I couldn't really measure it. The way that I'm measuring ROV deployment is by using the data from BGP collectors from route views and write. And what you see here in the graph is taking those BGP announcements, I am counting the ones that are invalid with respect to RPKI. And my idea for this type of measurement was initially to do a very conservative measurement to kind of increase the ground truth that we have of really which networks are deploying ROV. So the idea is that I'm focusing on a very small set of networks, which are the ones that directly share their full routing table with some of the collectors, either route views or write. What I'm doing in this graph is from that information for each of these networks, plotting the number of invalid prefixes that they share with these collectors. Here you can see that initially in 2019, these networks, they had a level around 5,000 invalid prefixes, and that at some point, this count falls down, and that's when they deploy ROV. Here we have the same graph, but with these dotted lines, and I put these dotted lines at the point where I could find some public document from these networks stating that they had deployed PKI validation, ROV. And you can see that it kind of matches a lot, although there are some ups and downs, and I'm going to talk a little bit about it. But basically, this is the gist of this methodology. because we can use all these longitudinal perspective with the collectors, when I detect a huge decrease in the number of invalids that a network is sending to the collectors, I consider that network has deployed ROV on that day. Here is a graph using that measurement for all the networks that share the data with the collector. These are the percent of networks that I'm able to measure that they are deploying ROV. When I started doing this, it was in 2019. You can see some deployment, and that at that time it looked like huge. But then there was all this wave of deployment, and now we're in a much better position. From the ASs that I'm able to measure, and you see that there are not that many, I measure a deployment of about almost 50%. But these tend to be larger ASs and ASs mostly in Erin and Wright. And that's where we see most of ROV deployment. So with this technique, I'm able to measure between 315 and 320 for IPv4, a little bit less for IPv6. And on June this year, from those numbers, I could count about 155 AS in IPv4 doing ROV and a little bit more in IPv6. But IPv6 is a little bit biased in the sense that there's less ASs that share IPv6 information. So that's why the percent sometimes is a little bit higher. The other thing that I'm able to do is because this is longitudinal and I can repeat this measurement every day and also historically, is when I look at all the data, for example, in the past, I took it the past year. And for every day looking which ASs I detect that have a lower count of invalids with respect to what they usually have, like a significantly lower, I require like 70% lower. I can count that there are unique ASs 303. That means that there are networks that are sort of turning on ROV for some days and then they turn it off. So they're not, I don't consider them in these more transient monthly measurement, but I do see them doing either testing or maybe they tried to deploy, then they did not deploy. And I'm going to talk a little bit about this with the next graph. So here, the same graph looking at the count of invalids, but of large networks, so tier 1 networks. And you can see here, when the networks that, like in the previous graph, they start deploying ROV and we see the counts go down. You can also see something that I think it's really interesting around all of this time. You see this is going down. And this line here gives me more or less the level of invalids that are flowing in the internet, or at least in the part of the internet that we're able to see through the BGP collectors. Even with the deployment that we have now in ROV, there are more or less 3,000 invalids going around. But before there used to be like 5,000. Now you can see that this number is again going up a little bit more. And here are two forces that play, that there's more ASs deploying ROV, which reduces the amount of invalid prefixes floating around. But there's also more ASs registering ROAs. And the more ROAs we have, the more likelihood that we're going to have some invalid prefixes. So these are these two forces that you can see here in this graph. The other thing that you can see in this graph is, of course, the up and downs. And that's when a network, here you had a few days, you can see the blue line, that some days it was down and then it came up. I've reached out to some of these operators, and some of the reasons are what Tijay said. So there's issues with the router software. There's also sometimes issues with whether they're using certain connections with the TAL and it's working. Sometimes there's issues with relying parties. The other interesting thing that I have to, sometimes when you zoom into this graph, you can see that when a network starts deploying ROV, the level of invalid reduces, but not here that networks have different levels of like how much they reduce the invalid prefixes flowing through their network. And this actually tells you about the policies that they use to deploy ROV. Are they filtering their customers, or are they reaching out to customers that have invalid? If the number of those invalids are like higher or down, that is going to show up here. For example, usually networks that filter for everybody are really close to zero, maybe less than 10 invalid. Networks that are not doing ROV for their customers, they can have maybe less than 100 invalid, and there it depends how much they reach out to their customers, asking them to fix things. And then you have networks, for example, there's quite a few networks that do not include the Erin TAL, which means that they when they are doing ROV, they do not process any of the ROAs, like the cryptographic elements for the airing region, for usually legal reasons or policy reasons. They don't want to sign or appear as they are signing an agreement with airing. So it's not included in the software. And when that happens, then you see a level about like 500, 700 of invalid from that region. The other thing that we can do by looking at the data from these collectors is actually to have a sense of the impact of ROV in prefix visibility, which relates to how ROV is limiting actually the spread of invalid prefixes in the internet. Here, I'm first going to show you, and this is the plot that I did back in 2019. So the blue and green line are the valid or unknown prefixes. And you can see here, these on the x-axis is the level of visibility in the collectors. And you can see that most of them have more than 80%. Whereas you can see the invalids, whatever reason of prefix are invalid, they have lower regions. So even at that time, already in 2019, when we had less than 10% deployment in what I could measure of ROV, we could see that difference in visibility. And look at now. So this is the same graph. I just put invalid, both of them together in May 2023. So using the same type of data, the data from collectors, the blue and green line are almost close here to 100. And you can see how the invalids have a really different level of visibility, where 99% of them have less than 50% visibility in today's collector. Of course, there's a few of them that reach higher levels of visibility, but you can also see that none of them actually reaches more than 80% visibility. And all of that is due to ROV deployment. The other graph that I've done, and just to show you how these have changed over time, and it has changed as networks have deployed ROV, is that I'm just going to show you how the visibility of ROVs has changed in the past few years. So the IIJ initiative publishes data for prefix visibility and their RPKI status. And now I'm using that data. And here you see it for July 2021. Then this is November 2021. This is June 2022, December 2022, and this is now. So you can see how actually, as more networks are deploying ROV, the visibility of invalid prefixes changes. And the other thing that is interesting that we can do with the data from the collectors is that we actually can also look at prefixes from specific regions. And here what I'm showing to you is the visibility of invalids, depending on whether they come from the ripe zone or from the airing zone. So whether they're in the ripe tile or airing tile. And you can see that in July 2021, a big chunk of airing prefixes have higher levels of visibility. So here is 50% of the middle, and you can see that like 70% of them had 50% or more visibility, whereas in ripe, you only had maybe 30% that had 50% visibility. And that is because some of the networks that deploy ROV, they do not include the airing tile. That is also changing over time. airing has made changes to their legal agreement. They're trying to make it easier. Some networks do not agree, but there's definitely some progress into more networks, including the airing tab. And you can see now, this is the same graph for May 2023, that the behavior of both of those cumulative distribution function is much more similar, which indicates that there's more similarity in the deployment of ROV, including airing and ripe. And with that, I leave it to there. So thank you so much.
Thank you, Cecilia. A very interesting set of graphs about the longitudinal and also the evolution of and how it affects visibility of invalid prefixes. Great. So maybe we can start the discussion now of the panel. And people in the room, feel free to either raise your hands if you want to ask the question verbally, or just add it in the chat, and then we will take it up to the panelists. But maybe the first question from me is, so talk about the challenge of having ground truth in every technique. Basically, when you're trying to measure ROB, as it stands, I guess it's still a challenge. What do you think maybe operators should do or improve, or maybe an organization like the Internet Society can help through the Manners Initiative to increase the amount of ground truth that we have on ROB? Anyone can take the question. Feel free.
Yeah, actually, when I work on this Rovista project, I really get benefit from ISO because the survey was really helpful. Because I think maybe because there are couple of hundreds of participants in manners, if we could leverage that opportunity, maybe sharing the surveys on every quarter, asking about how they use ROV on in for each where they learn the roots coming from, or how they use, for example, IRR, that would be really awesome. Yeah.
I
Yeah.
agree with TJ. I think in manners, you're in a unique position where you could have an effort to document all the processes related to ROV when a network deploys it. Manners doesn't really require Unity's action. It supports it and promotes it. But you could document the process of what it means to deploy and also what it means for the network to actually deploy. And another way that I've been doing is just sharing my graphs with operators, because when you can see the data, some operators or people that were involved, they're more likely to start talking about it. So the other day when I shared it with them, they were like, oh yeah, that spike happened because that's when we found out that in this router, this was going on and we tried to do this. And then we figured that we need to stop and then go back. And so you get part of that story. Some of the networks that I showed, for example, I think one of the KPN ASS that turned ROV on in 2020, they did it very slow. They started like by peers and then tier ones and at the end customers. And you can see their levels of imbalance going down. So when I showed the graph, oh yeah, we started doing this for peers and then we figured out that actually the hardest one were tier ones. So then we treat this. And you can see the graph going down. So then you take, so another idea is like sharing this, maybe say, hey, we believe that you're doing this. Can you confirm to us? And like, and then what challenges have you done? So I think any measurement, what Tijay is doing, that we have some data to show can spark these conversations.
I agree, and I think we need also more uniformity in the components in RPKI. One of the main components in validation for ROV is the relying parties. And there is a tendency to go on the cloud and provide it as a service. And some networks, they use on-premise on relying party and another relying party on cloud and or in another network, and which is great. But one of the side effects of this is that depending where you have the relying party and which relying party you have, you get different validation results. And so depending on what relying party you use, you will have different routing decisions that you will make. And it is interesting to understand. We are working actually on understanding what these differences mean, but certainly this shows that there is need in uniformity of the different implementations. And this starts with, for instance, different thresholds which the implementations use. Or different implementations use different thresholds. It doesn't matter which threshold. There are thresholds on the communication latency. There are thresholds on the refresh interval. There are many different thresholds. They're all different. And the choices of the thresholds are also not clear. Like, what is the thinking behind, what is the reasoning behind selecting these thresholds, these values, and not other values? And all of this, of course, has implications for connectivity. And so I think in this RPKI started as test implementations which were more like prototypes, and they were meant to see how this all works. But we haven't noticed that in the recent years we moved to production environments and using kind of prototype implementations on production environments, on environments where we soon will have to, these implementations will have to cope with a lot of data, with a lot of information. Imagine when an RPKI is fully deployed, what implications will it have on the size of on the size of the repositories and the number of objects that you have to download, that you have to validate? What implications will it have on the refresh intervals? Because maybe by the time you finish validating everything or the relying party, it has to start another refresh intervals. So the differences in the different implementations and the logic which is used for selecting different parameters, I think they have to be clear and have to be uniform. And this will allow also to understand the impact of RPKI validation now on reachability and propagation of invalid routes now and also in the future when RPKI is fully deployed. And this will, I think, this validation will or evaluation also shows or will show that current implementations, they are not suitable for a lot of data in production environments. Not just the differences in the different parameters, which cause discrepancies in the VRPs, which in the validated payloads. So for the same networks, for the same repositories, if you use different relying party implementations, you will get different sets of validated payloads. And there are different reasons for that. But all of this shows that we use RPKI in production, but it's not ripe in a sense, it's not baked yet to be used in a production environment. And so I think we need much more uniformity and we need to a better understanding on what it means and what implications it has on real world networks.
Thank you, Haya. I think you touch on a very important aspect. So the reliability of the supply or supply chain is extremely important. And for example, we rely heavily on the RIR's repository and also dedicated repositories. And in many cases, we have seen that some repositories are just not responsive. And this, as you mentioned, Haya, gives differentiated type of validation results, could impede the good processing of ROAs. Yes. What do you think? Talking about the deployment of ROV, what do you think should focus on the deployment of ROV? These tier one operators, or these transit providers mostly, or for example, IXP should be all dropping ROVs. What are you using?
Some maybe I can start with answering this question because I think all of us are exploring this direction. So in a recent research we did, we found that ROV on route servers in IXPs, they provide only a local protection against hijacks. So they will limit the propagation of invalid routes to a local scope. While on the other hand, if you deploy ROV on tier one providers, then they provide protection in a global internet. So they limit the propagation of invalid routes globally. And in fact, this means that if you want to limit the propagation of invalid routes globally, in the global internet, we definitely have to have tier one providers, but in combination of tier one providers and IXPs, you will be able to reach both the global propagation and the local propagation, which the route servers allow. Now, the problem with route servers is that they also have direct sessions. And although we saw in many places that route servers, they guarantee if you use ROV on route servers, or if you use the route server ROV, then you prevent propagation of invalid routes. This is not so because of the direct sessions. And so the idea is indeed a combination of route server ROV and ROV in top providers. This would certainly limit local and global propagation.
Yeah, I agree. Because when I started this research, there was a one paper from your group, the NDSS simulation-based study. So you can directly show that the tier one and the SK comes down to the tier two and tier three. So then the ROV has to be deployed at the tier one first, for sure, because it will offer the collateral benefit to all the rest of the internet easily. Oh, by the way, we have one question from the audience.
Yes, actually, it's a very interesting question, the one from Thomas. But just to tap on what you're saying, I think here there is, I don't know if a dilemma in, the best, definitely tier ones to deploy. But if we're thinking at the beginning of ROV, how are you going to get a tier one to deploy this new protocol when tier ones manage like really complex, huge networks with a huge amount of routing messages coming here and there? To deploy something that has never been tested in the operational environment more than in a very limited way. So if you think about how do we get these kind of new things deployed, it is never the case that the largest institutions are the first one to adopt innovation. Like that is in just for them, the risk of something going wrong is too big. That's why if you look at the very first organizations that deployed ROV are not tier ones. There were a few research networks, although now it's not that they are the ones that deployed the most, then some tier 2, like very small tier 2. And then, like, for example, AT&T was one of the first tier 1 networks to deploy, and it was already in 2019 or beginning of 2020 when we could already see other networks deploying this. And that just makes sense because of the complexity of their networks. And this jumps a little bit on Thomas' question that is on the chat. So he asks, what can we expect for ASPA, this AES provider authorization, which is a new, I would say, protocol or addition to BGP that is being worked at the IETF. And I think from that process, looking at the process of RPK adoption, and I wish there was more research. If somebody wants to do it, please reach out to me. I'm very interested in this. How we can learn about how this ROV was deployed, for then the deployment of other heavily decentralized protocols. And for me, something that I've learned, like talking with operator, a big difference between RPK and ASPA is that if you think about it, RPK was standardized. I think the last the set of RFCs that define RPKI in 2012. And we start seeing the first deployment of ROV. So then, of course, there was the deployment of ROAS. But you can issue a ROA and nothing changes in your network if there is no ROV. Then the first deployment of ROV, it comes like 2017. So about 5 years after the RFC was standardized. And that brings challenges. And it also means like, why 5 years? Because there was not much connection about what was going on in the standard and what the operators were doing. And some of the challenges with RPKI and all these the software issues that we measure in the routers, and these are routers that are like at this point maybe almost 10 years old, that they got the first implementation that router vendor did of RPKI, but nobody was using it. So those implementations were not really tested when they were put into the routers. Then five years later, somebody turns it on and figures out there is a bug in that, and then they raise it to the vendors, and the vendors like, that code is already 5 years old. Like whatever this is 5 years old, nobody has touched it, and it's a whole challenge to actually improve that. And that's why some of the Juniper routers, they're still waiting. So some of these routers, they're still not managing ROV the proper way, or in a way that is compatible with the policies that traditionally is used in their routing. And that's why they don't turn it on with those routers. In ASPA, there's a big change that there already is some implementation of ASPA thanks to Job Snyder and some other operators. And the standard is not even standardized. And actually doing those implementations, they figured that there were some details, and they actually changed the standardization for that. So that is, some people were starting to think about implementations. Now they changed the standard, they need to change the implementation. But because they did these first few implementations, they learned that, and it's changed now before it is a standard. So I think currently ASPA is a little bit more hand in hand between who are going to be the early adopters and the people that is writing the standard. And I think that is just better for everybody. That's my view.
Yes, we learn a lot from running code. Yeah, definitely. It's a good way.
But that's indeed the point, that we start with test environments, we run in test environment, and then we forget that it was test. All of those implementations, they were kind of prototypes that were not made for production environments, and then we start using them in real environments. And I guess the large operators, that is how they started, that they have this as a test thing. They were trying to see how it works. They haven't really been using it to make routing to influence their routing decisions. And then you see that it works well, this small thing, and then you start using it in real life. And then this changes, I think, because it's not the same to be using something in test production. So I agree with what you, Cecilia, you're saying, that this means that there has to be some transition period between test environment to real production environment, not with using the same software, but with using a production grade software.
And also, one thing I would like to learn from big network operators is, for example, when I use Rovista to measure ROV scores, some big giant networks like Verizon, their ROV score is 0%. What I was really curious was there must be some reasons why they're not using ROV at all. But when network operators deploy ROV, they write a very good blog post saying that our network is secure, blah blah blah. But when they decided not to ROV, then there is no information at all behind that decision. So we have to talk to them. Yeah, that is something we have to learn from the network operators why they're not using ROV, just to learn that we to prepare the next one ASPA.
And quick one, TJ, from your research on ROV, did you categorize the type of networks doing ROV? Do you have an idea of who is doing ROV?
Actually, there is no kind of clear separators between the ASs who deployed ROV so that their score is 100% versus a small network operators who are not using who did not deploy ROV but achieving 100% because of their upstreams. What I guess was just the tier one network operators who don't have, providers, and big network operators that only have just the tier one providers. If they achieve 100%, then we guess that they might have deployed ROV, but we don't know for sure. So we have to use some, other techniques. Yeah. That is one main challenge of my technique, the Rovista. So we don't know for sure if network operators have deployed ROV or not.
On the filtering side of things, so Manus has this action one, which is compulsory to, if you are an operator and you want to join Manus, that you need to be filtering your network. And the filtering is either using ROV or IRR. What do you think of this tension between IRR filtering and ROV? Is this something that you discovered while doing ROV research, ROV measurement, that how predominant, for example, IRR filtering is, and is one actually competing with the other?
Well, I think
Okay,
okay,
go ahead.
TJ, go ahead.
Oh yeah, yeah. So I try to talk to some network operators to understand. When I first started this research ROV and RPKI, I thought that, all right, why don't we just dump IRR, which is really nice? And the network operator said, hey, we are using it because of to prevent from route leak, and also when we make a peering relationship, we have to let them register their IRR object so that we can guarantee before making a connection. But it is also, as we all know, the IRR objects, sometimes we cannot trust them. But still, when we see the manners participant, many network operators still use IRR. So we have to use them together, right? But we, at the same time, while we are focusing on our PKI, but also at the same time, we have to think about some methodologies to improve the quality of IRR. That's my 2 cents.
Haya, you wanted to say something?
Yeah, I agree with with DJ's 2 cents. And so to avoid any IRR filtering in our measurements, we create correct objects, but all the rest is also, I'm seconding what TJ said.
Yeah, from a measurement perspective, the challenge of using IR is that policies with IR are very specific to the prefixes. So already in RPKI, you have a variability on how it is deployed ROV, like whether it's for every single prefix, from everything but customers, only for certain networks. With IRR, is a whole lot. It could be just a few prefixes from this network or a few things from that. So it's actually very challenging to know that network is filtering out that specific announcement because of this IRR object, because you have a equivalent one that somehow is not filtering an announcement. And you're like, okay. And so that is much more, we would need a much better understanding of what our network's doing. And at a level that sometimes even networks, they don't know themselves. Because sometimes I've seen disparate things. I've touched a little bit upon that topic, especially when you compare IRR records that are incompatible with RPKI. You get a set of things that are not the same. And trying to figure out why networks either choose one or the other. And sometimes some of them is like, oh, look, my network does RPKI. This is what we do. We say, but we manage this part of the network. These company, this operator is big enough that those other groups over there, they manage their things, and nobody and they answer in the organization to completely separate set of people. They have other priorities. We cannot touch what they're doing. They don't even. It's like complete disconnection of groups within the same organization, and nobody has really. They can say, okay, for my group, we do this, and this is how we're planning things I'm doing, but I have no clue of what they're doing there. I have no way of influencing whatever they're doing, and it's just their own thing. So even for one company, even these large operators, is very challenging for themselves to really know. They were like, oh, I didn't know that group was doing that.
Yes, one network operators that I had a really interesting experience. One network operator told me that after I presented this work at the Manners workshop about 2 years ago, and the one network operator reached out to me, hey, your Rovista users say 0% or 10%, but as far as we know, we actually deployed ROV, so it should be 100%. But after communicating back and forth many times, it turned out that ROV was managed by some other teams, and it was some mistake. So it was not actually deployed at all because big network operators, they have many teams, and it should be some complexity. So that was one of the challenging point to figure out what if something doesn't work, and who should be responsible for that. Yeah.
And back to the question of what you mentioned about that, TG, the collateral benefit by deploying RV. So maybe we need to, there are some maybe training or awareness campaign that we need to do to operators to tell them, okay, maybe they shouldn't rely too much on just relying on the upstream doing ROV. Maybe they should also be dropping the invalid when they receive the announcement, because maybe they are multi-homing, they have one operator, one upstream doing ROV, the other one is not doing ROV, and how is traffic shifting from one to the other?
Yeah, it is really difficult to answer, but that should be related to what Haya said before, because as far as we know, we don't know, but some network operators relying on some cloud public VRPs like Cloudflare's VRPs produce JSON file, or Ripe's produce VRP JSON file, but some of them, they just download all the RPKI objects and validate themselves. There must be also some reasons why network operators, they don't download all RPKI objects by themselves and validate them by themselves, right? So we have to understand what is the reasons behind using third-party services for filtering invalid BGP announcement, which does not sound good to me, but yeah, I just wanted to understand. Yeah.
I guess it's like with any outsourcing, it reduces the overhead for you that you have to update, you have to patch, you have to take care of this. It crashes often. It can happen that it crashes, and you don't need to check any problems that happen. And also you can figure, you have the stable, reliable source or a number of sources, and your router just receives this information that it can use in making its routing preferences. So I guess that's the reason. And the motivating deployment higher adoption of ROV filtering, I think this would have been easier with financial incentives. So imagine you attract traffic if you do ROV. Of course, you would immediately have many networks adopting ROV filtering if this suddenly attracts more traffic, because this creates business. I think we have to couple mechanisms that we develop with financial motivation, because that is what is driving the world. In Europe, I'm in Europe, so there is a lot of discussion about digital sovereignty. And this means producing the software ourselves here. But on the other hand, this is all a question of cost, because if this is cheaper from the providers in the US, then this is no question. And I think the market is driven by economic incentives, and the same is no different in the internet. And so we just need to develop protocols or adjust them so that they provide economic incentives for deploying them. And then you don't need to convince anyone that they should deploy it. Of course, it has to be stable and it doesn't have to create new problems. But other than that, I think this would be the best motivation. Then you don't need to go outside and tell everyone, please deploy ROV, because it will prevent prefix hijacks. Because perhaps, okay, they get a couple of prefix hijacks, but this is not such a big problem for them, because on the other hand, they get revenues for all the traffic that they do not lose.
Yeah, I really agree. There are some great examples of giving a economic incentive in DNSSEC. For example, .com, .net, .org DNSSEC deployment rate is less than 4%, I believe. But in case of .nl, .ch, .se, more than 50%, right? Because they are getting the registrars can get some financial incentive from the registry when they use DNSSEC. Yeah, maybe that could be a catalyst to deploy ASPA, maybe. Yeah.
It could be economic incentive, or it could be some push or incentive from governments. For example, if governments would require that, not require RPKI or anything, but say, okay, if for transit, for anything related to the government, we need to use networks that deploy ROV. That would already give an incentive for some of the networks. Because part of the challenge that also ROV has is that when you look at how routing works and who ends up with the harm of the hijack, it's actually very far away from the network that needs to do the action of deploying ROV that could have limited that hijack. Because if we look at previous hijack, who bears the harm? The owners of cryptocurrencies whose wallet got stolen through using a BGP hijack. But it's very far removed from the operator that needs to deploy ROV. And that is one of the challenges why there is not a direct economic incentive on doing so. But that can be changed. And I also think bringing awareness of this also helps, because then the customers of networks can start requiring, if you're a cloud business and you're like, oh, I'd like to protect all my infrastructure, then if you will use a network that deploys ROV, it would be better for you. The same way that maybe, for example, for really critical infrastructure in DNS, there could be a push that infrastructure needs to be hosted in a network that deploys ROV.
Yep.
Yeah.
All of these little things can help.
So completely agree. And I think going back to the question of Thomas Holterbach, which was a very good question, I think that the effect or the motivation or the damage effect, if something happens in RPKI, will be much more significant for ASPA, right? Because if you cannot download objects to validate them, or something happens with the relaying party, then this absence of information for one specific link will cause the entire path to disappear. And so the effects of instability, and currently RPKI is not stable enough for production environments. This is my impression from my experience in this research topic. An absence of information may cause the entire path to disappear. And so we need much more stable RPKI before we go and we try to convince real production environments to deploy them. And so I think we are not there yet. And by the way, my paper on the RPKI in 2017 was, are we there yet? And I can tell you now, we're not there yet.
Still not yet.
We're not there yet. And I think the implications will be much more significant than for origin validation. They will be much more significant for path validation. And so I think we first need to have a stable RPKI to be able to start using things like ASPA.
Also because ASPA, actually, the records are going to be in the RPKI. So it's going to use the same, at least all the RIRs, the same infrastructure there. Then, of course, the routers need to change. but it's still going to use that part of the infrastructure.
Yeah, absolutely.
On the stability of the let's call it the provisioning system of ROAs and OPKI objects, do you have any message to maybe the RIRs or those who are hosting a delegated CAs? How robust the system must be, how high the availability should be, things like that?
Certainly, this is not something that one can say in one word, that we have a simulation for simulating an internet at a full RPKI deployment, during a full RPKI deployment by extrapolating. So this is a paper that is coming up at SIGCOMM this year that we have, and with further problems that we found in RPKI, but also simulations which show what will happen at full RPKI deployment, where we extrapolated by looking at the historical deployment of RPKI. We extrapolated what will it have looked when RPKI is fully deployed. And this is what needs to be done. Such simulations and extrapolations need to be done, and you need to have a hardware which supports it. And I think for developers developers of RPKI components, they require much more investments, and maybe because now internet security and stability is such an important topic for, like you can see from the FCC in the United States, the executive order to secure the internet infrastructure, but also in Europe. I guess the next thing would be for governments to much more financially support research on this and developers of RPKI, so that we move of RPKI component, so that we move from test environments and test components to real production grade appliances or infrastructures, and they have to be tested on not current RPKI deployment, because Tijay says, like Cecilia is saying, this is changing all the time. So what we need to have is a number of models, how we assume RPKI will look in the future. And we are talking all the time about the 5 RIRs, right? But everyone can also host repositories themselves. And clearly you would say, to me, to host a repository, there is just such an overhead. I have to set it up, and I have to have delegations from the RIR, and I have to do this and I have to do that. But on the other hand, just one cyber attack against an RIR, and I think this may change this trend that most of the networks now using the repositories, the RPKI repositories of the RIRs. Just one cyber attack against one RIR, and you will certainly start seeing large networks and large operators setting up their own hosted RPKI repositories. And then, of course, this will have an impact on how RPKI will look in the future. Because even if we will project now that there will be, let's say, 100 or 1,000 RPKI repositories in the future, one one event can completely change this trend, and maybe we will see 10,000 repositories. The implications on latency for relying parties are going to be horrendous, because can you imagine a relying party having to connect to 10,000 publication points? You will never manage to do it in a refresh interval. But what does it mean? This means that we have to rethink the expiration time for the objects, for RPKI objects, for manifests that we currently use. So this is just one example, but it has so many different implications for the future of RPKI, or how will it look. And so what I think we have to do is, and this is the first step that we did in this SIGCOMM paper. This paper that is coming up is that we showed that the new thresholds which the CDROP operating groups defined for relying party implementations, they are vulnerable, and we showed that you can attack all of them. And not only that, they also introduce problems, these current thresholds. They introduce problems with the current state of RPKI deployment in the internet, because you lose objects, because sometimes the latency exceeds the thresholds. What is reasonable thing to do, I think, is to do the next step and to do really a real serious such simulation and extrapolation for different scenarios. What would happen in the future? How would internet look in the future? And how many networks? And I'm not even talking about IPv6. This was until now all IPv4. This is another complication that adds there. And if we want to have a stable production grade RPKI, now we need to plan it for the future. It has to be flexible and it has to be resilient. And I think until we have it, I think there is no chance that we will be talking about pass validation, ASPA, VGPSec, or any other things for which RPKI is a prerequisite.
Thank you, Haya. That was a very good conclusion, because we will have already reached the end of the session. Great, and I think you also replied to some extent to Ebrima, who had a question about ROV simulations. Work on ROV is extremely important. I don't know if there is any specific framework to do simulation. I know there's the mini internet. Thomas can talk about that later. But yeah.
I think maybe the question is not clear. It's like simulation, what ROV, in filtering ROV, what impact does it have on propagation? How does it have on propagation on routes in the internet? Is that the question? If yes, then there are of course different simulation frameworks.
Yeah. Perhaps it's both RPKI and ROV simulations.
And if
Great.
it is a network deploying ROV, there are some, I think RIPE has, you can test what would happen if you deploy this ROA and what is the impact on your routing table.
Yeah. Thomas, you're in Strasbourg, no? I'm actually going to be teaching my students in winter semester, in winter semester, how a lot on RPI, and it will be focused on the tools and simulations and so on.
Excellent. I would like to thank you all for this very interesting discussion. Thank you for the time spent with us and the presentations that you did at the beginning. Thanks a lot. I hope we will get more opportunities to talk about ROV in the future, and well done on the research work, and also good luck for those who are in the publication process. And we hope to see more research work on this topic in the coming months and years. There is a last poll question, and I would like to ask the people attending to just put what was your biggest takeaway from this session, and it will help us improve perhaps on the next editions. Thank you again. Thank you very much. It was a pleasure having you today.
Thank you.
Thank you very much. Bye-bye.
Take care. Bye.